guess any questions?
Have you run it, and how much does it cost?
A lot. But how much engineering time cost?
No, I'm just curious.
Significant amount for like a medium-sized company, but the way that we can iterate on a pace that we never seen before, like in many cases we can receive the working POC in 20 minutes on a call with stakeholders, like this process will involve 5 people back in the day. We don't want to use AI, and we don't want to use it for everything because we kind of don't trust it in many cases, but it's always going to be the use cases in your work and your process which you just don't care. Mappings, API calls, data transformation, something you can easily verify and see by your own eyes. I think there's something.
How do you evaluate the agentic AI?
Well, you evaluate it. Sorry?
Can you repeat the question?
How you evaluate agentic pipeline. Well, that's a beautiful part about temporal. From the temporal perspective, agentic pipeline is a huge workflow, which, yes, you can test by the steps, and you can make sure that all of them work from the workflow perspective. However, from the user, when you send the command, it's just a function. So you evaluate result by evaluating the quality of the function result. If you're doing something that is going to be fetching information from your database, like RAG pipeline, there's a bunch of solutions on the market which can rank it and see how well it correlates with actual information. So you evaluate result without actually evaluating all the steps taken inside. You kind of don't even worry about them. Agent is willing to do what he thinks is the best. Yeah?
Why were you choosing child agent flows instead of just saying tool calls?
Sorry?
Sorry, why were you,
Why would we choose using the child agent if so? Good question. I mean, the reason for that is because the context window of each of the agents is limited. It's quite large, but still it's limited. So if you have to perform a simple action that can only be done based on information that can be collected from many different parts of the system, by just collecting this information, you're already going to overpollute the memory of the agent, and he's going to just be working much slower and much harder and much more expensive. So instead of that, you want to isolate this process and only get the result.
How do you run the AI generated tool? Because it can be in different language, right?
How do we run what, sorry?
AI generated tool.
We run it right in the temporal. So like the thing I didn't say in that presentation, the referencing layer, which was a single slide, is actually where we spend the most of our time. Because when agent defines the tool, we actually define it as part of our system, which we use temporal as syncing layer to sync it to our runtimes, which makes it immediately available for AI to use. So basically, by AI creating the tool inside the system, it automatically declares it and makes it available to AI if it's been connected, in declaration of this agent. It can be any language at the end of the day, and we think that eventually the language, when you work with the application, is probably going to matter less.
Is there any other like temporal specific limitations or things that you ran into that you didn't expect?
There's few, but I mean, they're not that large and they're not that much different from what you will do in temporal. If you run a very long decision chain, the agent that can span from many files and run many iterations, you're eventually going to run to the position then when your workload just has to be restarted. And restarting the workflow that has hundreds potentially of child workloads in a tree is quite a challenge. So you might need to implement your own mechanism to properly collapse all these workloads and restart them over in the next iteration. Well, right now we validate it by the user observation. You just test it right in the mix, so you see if it works or not. We don't try to create, well, huge application servers using these tool calls. We just create a simple integrations, which are much easier to test. But at the end of the day, you can actually feed this tool back into the agent, and that's another property of the reference layer we create. Every tool that agent create, they actually become part of the knowledge base that agent can use to learn to create new tools or read existing tools and analyze if they work correctly. Or they can just generate the test.
We have one more question.
Okay, I wonder if you have any advice in terms of how to deal with the throughput of the LLM models themselves. Typically in an environment like this, you would have a shared LLM resource, and it can get pretty overloaded if you have, let's say, a big chat.
Well, you can move the LLM calls to the separate task queue and have a rate limit on this task queue. That's about it. But in our case, we actually have our own backend that encapsulates all the LLM calls where we have additional priority queue with additional rate limiting. It's a simple kind of side effect that we allow multiple organizations use the same model, but at the same time, we can split the model use between organizations, so they never collapse in this regard. But at the end of the day, even if you don't have it and it fails, well, it's just going to be retried.